Thank you. It's nice to be here, and this paper is joint with Jonathan Eaton and Francis Cremars. And well, this is in the literature following the revolution of having microdata started by Bernard and Jensen, and a big part of that is trying to come up with models provoked by these new facts that come about. And so I think one motivation of this paper is very much like what Paul presented, of kind of trying to treat exporting and importing in a more symmetric manner, because after all, some of the facts are quite similar about importing and exporting. And another part, another aspect that we're bringing out here is that importing is very much linked to the labor market, because imports to some extent are competing with labor at the level of individual firms when you're thinking about imports of intermediates. So that's going to be another part. And the style of the model we're going to have fits very much into Thomas' question. I was hoping you would ask it when I was here, because whereas we have there's some aspects of the paper we just saw that I would wish we could incorporate into what we're doing. One thing we are able to do is kind of complete that circle of really treating firms that are importing. There's a distribution of those which generates the model of exporting, and so there's kind of a completion of the circle. Everybody's acting as both an importer and exporter. And I take that idea from Bob's paper of people meeting and then generating a distribution so that the people they meet have a distribution and then they become part of that distribution and so on. And that kind of way of thinking was pushed by Ezra as well in his job market paper and the paper we saw yesterday. And there's another aspect from Stefania's thesis that we will incorporate as well, which has to do with this imports versus labor, where the firm's making this decision of whether they can get an intermediate cheaper by outsourcing than they can get it from within house. But let me go, I've saved this point till the end because I wanted to get across this bigger picture and then narrow things down where I think I'm going to be able to deliver more. After all, this is a paper still in the works, so I'm not going to have as complete a bottom line. But when we first started looking at the data that Francis had for French firms exporting, we eventually found this picture to be a nice way to look at the relationship between the number of firms that export and the size of the market they're exporting to. And the way we did this is by normalizing taking the number of French exporters exporting to a particular market country, denoted by the three-letter abbreviation here, say Japan, US, Canada, USSR, et cetera. And we normalized that by French market share, and then it had the feel of the total number of firms exporting to that country, because we saw the French firms, which were a share of the action. So we took that number just like a statistician would do when they only sample part of the population and divide it by the share of France in that country. And that's where we came up with this vertical axis here. And when you do that, the data line up very nicely along a line on a log-log scale. And this was kind of bad news for the paper that we were coming into this work with, which was the paper with Bernard and Jensen, the BJK paper, because that paper would have had no scale aspect to it and would have said that line should have been horizontal. But on the other hand, another model is the Melitz model, where there's an entry cost, and that would generate an entry cost per country. And we were kind of pushed towards that model because of this picture. On the other hand, that model would have said it should have been a 45-degree line. It's not that either. It has a slope of about 2/3. So it's sort of like Melitz was 2/3 right and we were 2/3 wrong. But it would have never been that. In the end, the paper with in the end, we just sort of used this to back out fixed costs, but then that was sort of just throwing away the fact just to back out a bunch of parameters. There was sort of no discipline in that. And we've always kind of wondered whether there was a more natural way to explain why that relationship is like it is. And that fits into, actually, when I first went to Minnesota and I showed a picture like that to Tom Holmes, he was sort of dismissive and saying, you know, that doesn't say anything about fixed costs. That's just a very mechanical thing. If you have a big country, there's more firms are going to land in the big country than the smaller country. Maybe there's something kind of more mechanical behind the relationship. It's not so easy to build a mechanical model that's parsimonious, but in some ways, I think the model I'm going to present here kind of follows through on that vision. I mean, there's probably more going on than Tom would have liked, but I think it has that feel to it, and also has this sort of interaction between firms, both as importers and exporters, a la Ezra. Okay, so thanks to a paper by Kramar's, Julian Martin, and Isabelle Mejean, we have a peek at data that goes a little deeper than the picture I just showed you for France, and looks a bit on the importing side. But first, let's just redo. It's also more recent. That picture I showed you was 1986. These are data for 2005, and let's just start step by step. Here is literally just the number of French exporters and the market size just for the EU. And the reason we're limiting ourselves to EU countries is we're going to know something about the customers for these EU countries. So we'll know something on the other side of the market for each of these countries. But so far, we're just looking at the data the way we could have for our French firms. And the point of the picture I showed you before was, you know, you kind of lines up nicely if you rescale it you adjust by the market size, just like I did in the first one. So 20 years, sorry, I'm not counting. Yeah, 20 years later, we still have basically the same relationship. Here, the slope's about 0.5, and the other, the slope was about 0.63 or something. So it's changed a little, but it's a different sample of countries. But what we can look at now is we can look at the number of customers these French firms had in each of the destinations, sort of getting a little closer to the other side of the market. And what we see is that the market size goes up. It's not just that more firms are coming in, but each firm that has entered is selling to more customers. So that kind of gives a hint of maybe why that slope isn't one like in the Melitz model. It's just not firms pouring in, but firms are then spreading out on this extensive margin of more customers. So we're definitely seeing that upward slope. That's something we're going to want to see if we can capture.
That means like a third as a
These are firms. Yeah, we don't know a heck of a lot about them except a VAT number that's sort of anonymized, but that's where these data are coming from. So it's just how many different VAT numbers correspond to the customers of these individual French firms. Okay. So then one more thing you can look at, just in a little bit more detail, take some different countries going from small, very small, big, really big, in terms of destination markets. And then the mean number there, the market size is just like the x-axis in the previous thing. The second row is just like the vertical axis, but now we're not just looking at the mean, but looking at the different percentiles. We see that what's typical of these sorts of data, these real skewed distributions where they're way out in the 99th percentile, you're getting many customers, but throughout most of the distribution, you're really talking about just a handful of customers. Again, kind of suggesting maybe a model of individual firms meeting individual firms, which is what we're going to have, is sort of natural to confront data like these, as opposed to, a firm coming in and kind of selling to the whole market. Okay. So sort of the idiosyncrasies of it kind of come out here. Okay. And then I'm going to skip this. This is just kind of keep a foot in the door in terms of the labor market. I'm going to show you some theoretical results on that, but our our empirical work there is sort of behind, so I'm not going to push that too much. And as there's a lot of prior literature including the paper we're about to see and the paper we just saw. So very closely related. Okay. So a model of firm-to-firm trade. What are the elements? There are a bunch of countries. They're separated by iceberg costs. There's a continuum of firms. And then this is the key new part, is these firms are supplying intermediates to each other. So they're all interacting as buyers and sellers, and exporters and importers, because other than the DNI here, you know, it's the whole world. It's not just one country. Now, the key thing is each buyer, even though there's a continuum, each buyer only encounters a handful of suppliers. And that's really a kind of a black box in this model. Why is it that you don't observe an infinite number of potential suppliers? Well, that's sort of the friction that makes this model work. And there are different ways of thinking about it. It's just only certain goods really work for you as an input to what you're producing, or there's limits to how much you can search around to find all the possibilities, but that's an element of the model. And then we're going to make it as simple as possible. This model is very amenable to deviating from this assumption, but we're going to make the assumption that goods are sold at a marginal cost just to keep it simple. But the model's amenable to having Bertrand competition and so on. Okay. So the firm production process involves a bunch of tasks. For each task, and this is the Stefania part of it, you either could use labor or you could use an intermediate. Now, both of these have random prices in a way. The labor, there's a market price for labor that could carry out task K, but there's a random efficiency at the level of the individual firm so that the unit labor cost is random to the firm. And then for the intermediates, because of this search process, you know, the supplier you run into will have a price that's random. And that randomness, again, that's kind of the completing the circle point. That randomness is generated by the model itself. And then you're going to choose the cost that you're going to pay to carry out that task will be the minimum of those two things, the unit labor cost or the price of the intermediate. Okay, and then production is just constant returns to scale at the level of the individual firm. It's Cobb-Douglas across the costs, across the tasks. And if we think about a firm then, I'm just labeling it J. It's got its efficiency level Zj, and that's going to have exogenous heterogeneity in it. And then there's going to be this endogenous heterogeneity of the costs of each of its inputs. So a firm has many layers of heterogeneity. It has its efficiency difference, two of which you can see here. Efficiency differences, these cost differences, which themselves depend on two things, both the randomness in the prices of the goods they have access to and randomness in the efficiency of the labor applied to the tasks they need to get done. And then the firm is going to have a lot of heterogeneity on the demand side, because how much it sells will depend on how many people how many firms it runs into to sell to. So there's all sorts of heterogeneity running around at the firm level. Okay, and then in terms of a country has endowments. The labor market's quite standard and is not a search labor market. There's just a common wage for a type of labor, and then there's tasks can get done by certain types of labor, and that ends up generating then a task-specific wage, but that's really just the wage of the type of labor who can carry out that task. The reason we're putting in that sort of level of details to be able to talk about different types of labor being exposed differently to these outsourcing issues. And then we have a country is endowed, so the country is really just endowed with different quantities of labor of different types, and then that generates endogenously these task-specific wages. And then there's this technology, which as in Melitz-Chenet, it's just going to be this measure of firms who can produce with efficiency greater than Z, so that measure is exogenous. Okay, so specific assumptions. So this is just like, as I said, this is exactly what we assumed in the first paper with Kramars, the one I showed the figure from, this kind of Pareto measure. So that's a measure of firms who can carry, so that measure is parameterized by Ti, and then the heterogeneity is parameterized by theta. The workers are going to come in with this random efficiency, and that has this Frichet distribution. And we'll see where that fits in a moment. That is maybe, I mean, you can just remove that part of the model if you want, but it is, I'll show you how that works. A special case of the model is where, it's just a model of getting cheap inputs, and certain tasks get carried out by labor and other tasks get carried out by intermediates. But this distribution is crucial for making it work nicely when you try and combine and have this competition between labor and intermediates. Okay, so the matching technology says that the intensity, the Poisson intensity with which a buyer encounters a supplier of cost C is given by this E of C, E for encounters, I guess, not intensity, encounters as a function of C. So that depends on a parameter lambda, which is sort of the degree of knowledge about other producers in the, for task K in country N. And it depends on the measure of suppliers who can supply country N at a cost less than C, which is an endogenous object. But the reason we have this depending on this endogenous object is you'll see where that's kind of crucial in fitting the data. But the idea is that you're less likely to see the firms that are sort of further down in the cost, further up in the cost distribution, meaning they're worse. So the lower cost firms do sort of stand out in the sense that you'll encounter them more often, and making it related to the measure sort of says, the higher cost guys are kind of lost in the crowd based on the measure of firms who are better than them. And that's captured by the parameter gamma. I mean, you can have this statement is wrong. It's supposed to be 0 less than or equal to gamma, strictly less than 1. So I messed up the inequalities. But you can have gamma equal to 0, but with gamma equals 0, we're going to not be able to fit the basic facts very well. And so the gamma plays a crucial role here. OK. So now what you can do, think about a Poisson process. Normally you think about a Poisson process over time. And you go from the intensity, the Poisson intensity, to the Poisson distribution by integrating over time and saying how many things happened over this interval of time. Well, it's just the integral of the Poisson intensity, and then that gives you the Poisson parameter for how many things happened over that interval of time. Well, we can do the same thing here, but integrate over the space of costs from the lowest up to some level C, and just integrate up the Poisson intensity over the cost distribution. And that's going to give us a parameter for the Poisson distribution of how many firms a buyer is going to encounter with a cost less than C if this buyer is in country N. So that's just related to the mu n to this power, and it's proportional to the lambda, the meeting rate. So that's kind of a key step in this whole thing is that integrating up from the bottom up so that you're always kind of focusing on the low cost guys. Because if you ever see a lower cost guy, that's who you're going to buy from. So you sort of don't care about higher cost guys unless you haven't seen a lower cost guy. And so that's all we're doing here. So conjecture. 2 parameters of the model you've already seen. The gamma was the one that had to do with how much more likely it is to meet guys lower down in the cost distribution. And phi was the parameter having to do with the heterogeneity in labor. Now, I'm writing it this way because I think of it as a restriction. The model works if you just got rid of the phi aspect. And so this assumption is really about bringing in the labor in a way that's very tractable and in fact, very clear how it's working. But it's not, you can work with the model of firm-to-firm trade without this assumption. But if you want to bring in labor and outsourcing, this is kind of necessary to make it work very tractably. So anyway, the conjecture is, if that's true, then this mu n of c, this endogenous object, has this form. Now, this has a big question mark because we don't know what it is. But we're going to claim it has that form with c to the theta. So now go back to, so with that having been stated, we have this Poisson parameter here, which represents is the parameter of the Poisson number of suppliers you see as a buyer trying to carry out a certain task. So then you can say, well, what's the probability I don't see any supplier? What's the probability that the best price I see is less than something? It's just 1 minus the probability I see nobody with a cost less than pk. But that's just the Poisson value, the Poisson distribution at 0. So the probability of a 0 in the Poisson is just this e to the minus rho. That would be the probability of seeing nobody with a cost less than pk. So 1 minus that, you must have seen somebody with a cost less than pk. In that case, you're not going to ever think about, if you do see somebody with a cost less than pk, forget about thinking about suppliers with costs greater than pk. And then from that, we can get the expected lowest price, which is what I call this p bar. And here now we can plug in our conjectured functional form for mu. So we still got to nail down this upsilon n term, but that's going to take a few more steps. Okay, so this was just figuring out the price distribution for intermediates, given that you're always going to buy from the lowest cost guy that you encounter. But then you always have the option to just keep your own workers and forget about buying an intermediate. So what you really want to have is the distribution, the probability that the minimum of the unit labor cost doing it yourself versus the price is less than something. And that is so this is where that parameter restriction comes in. To make that a simple problem, we need the parameter phi to equal 1 minus gamma times theta, so that we're able to get a simple expression here for this combination of the cost of doing it with labor or buying an intermediate. And in that case, it has this functional form, and where the parameter here both has to do, is driven by the average lowest price of an intermediate and the wage for carrying out that type of task. Oops. OK, so now we get some stuff out. For example, the labor share, the probability that a given task is going to be performed by workers is just is related to the wage to perform that task divided by that denominator, which sort of combines the wage and the price of the intermediates, the average price of the intermediates. So we get a nice expression for the probability of outsourcing any task. And so that would say then that the share of type L labor is just going to be that probability multiplied by the share of that task in production. And the overall labor share is then just that thing summed over all the different tasks. OK, so now we get a kind of a model of the labor share here. So the idea is that this firm-to-firm trade is affecting the labor share, because you can, if intermediates are really easy to get, you're going to have a very kind of hollowed out production structure, very roundabout, where you tend to buy things from other people. Whereas if you're very autarkic, you'll kind of do everything yourself and not interact with other firms very much. And then labor will become close to 100% share of production. Okay, so we can finally now kind of complete the circle or confirm the conjecture. So let's start here. This is just a cost function. I've only made one change, which is to include the iceberg cost. So we're really saying what's the unit cost of a firm in country I delivering goods to country N. So it's just this cost function multiplied by D and I. Now notice the connection here between efficiency and cost. Were we to fix the cost that this firm receives in terms of it carrying out its tasks, we could say, how efficient would it have to be to deliver at a cost less than something? We can just kind of reverse the role of the cost and the Z, and then just plug it in to the measure of firms who would be. So the idea here is when we want to get the measure of firms who can supply N at a cost less than C, we just say, we start with saying, well, if we knew their costs of inputs, we could just say, what would be the measure of firms who are efficient enough to be able to deliver at a cost less than C. So the efficiency has to be above something for the cost to be below something. And in fact, the efficiency has to be greater than this for the delivered cost to be less than that. So we just evaluate the measure of firms for which that's true. And then, but these are random, so we have to integrate them out. But we have a way to do that because remember here, we derive the distribution of the costs of those task-specific costs. So we have a distribution of the task-specific costs, which takes account both of the fact you're either going to buy the low-price intermediate or you're going to do it with labor. And now we can use that to integrate out all these CKs in this formula and come up with this. Now, you can kind of see right away that some stuff's going to factor out. I mean, it's kind of easy. The C just factors out. There's a TI parameter here. It's going to factor out. And the DNI is just going to be raised to the minus theta and then get factored, or to the theta and get factored out. So, to the minus theta. So that's all I'm doing here is factoring out those terms that don't depend on the task-specific cost, and then reversing the order of the integration and taking the products because of my Cobb-Douglas functional form, and we end up just getting this one integral we need to solve in the end. And so doing that, and we had these parameters here. If we chose them cleverly to make stuff disappear, we end up getting this relationship here. So these are all the things to factor out. This is the part that we're integrating up having to do with the firm-to-firm trade part. All the lambdas are kind of buried in that term in parentheses. OK, so but then once we have the measure of firms from country I that can supply country N at a cost less than C, we can simply, which we had here, we can simply sum that up across source countries, both domestic and foreign, to get the overall measure of firms who can supply country N at a cost less than C, which is the thing we made the conjecture about. And so if our conjecture is right, then that parameter upsilon n needs to satisfy this expression here. So this is all the kind of guts of this term, which I didn't really show you before. OK, it's just kind of bringing out the guts of that. And then this is where this thing is very nicely behaved as long as there's at least one task with a positive beta with a lambda ki equals 0 so that you can't outsource it. And then it's just a nice contraction. You can just kind of start with a guess at the vector of these upsilons, and you just iterate, and it goes boom right to the answer. So that, since I don't feel that bad about having all of my firms have at least some workers, and that makes life very easy, and it makes it easy even while I still have the wages be exogenous. Sort of, it makes it easy even in partial equilibrium. It's kind of nicely behaved. Okay, so that's our completing this circle part. Okay, so now a few partial equilibrium things, just to get a little more of a, try and get a little intuition for what this kind of structure is doing. Well, the first thing, which we kind of figured out very late in the day, late in the game, is that if you think about the problem the following way, consider a representative firm who's replicating the production in this economy, and that guy's just facing these wages WKI and these average price of intermediates P bar KI. If that representative firm has this production function, which notice is not that weird, it's just a CES production function between labor and intermediates at the task level, and then Cobb-Douglas across tasks, then that representative firm will make the same choices, generate the same labor share as the model I just showed you. So as a model of labor, as a model of interactions between intermediates and labor at the aggregate level, the model is the same. We could have just written down this aggregate production function along with a kind of model of what's generating price changes for intermediates, and we would have gotten the same thing. So at the aggregate level, I think it's a bit similar to the fact that some of these firm level models kind of aggregate up to give, you know, Armington models or this and that model. In the same way, this firm level model, you can represent it in this more aggregate way as just this CES production function between labor and intermediates. And the intermediates could either be imported or domestic. And then the model gives you a nice way of thinking about how the price of those intermediates changes with, say, lowering trade costs or increasing the knowledge, the lambda, the knowledge about suppliers. Okay, so demand. The demand, this is very, to try and make it as stark as possible, I mean, he made the utility functions just like the production function. Households carry out a bunch of tasks, but the alpha case can be different than the beta case. Since the alpha case could be anything, they can be 0 for some of the beta case that only firms do, and the beta case can be 0 for Ks that only the households do, and so on. So we can be pretty general there. But I mean, it's a pretty stylized model of demand. But with that, we get a price index for consumers, and we now have a reason for producing these goods in the first place, which is ultimately households buy them. So, and they're no different. I mean, the ones that are used for intermediates are the same things that are used for final consumption here. So another nice thing about this model, much like the Melich scenarios, you get this simple expression for the trade share, which is just the measure of firms who can supply country N from country I at cost less than C divided by the total measure of firms that can provide country N at a cost less than C. And the C's cancel out, and then you get this expression. And these two terms are familiar from gravity type models. And then the term in here just shows you that there's a kind of a more complicated interaction between the cost of intermediates and the wage in the exporting country in generating its cost of production. But in the end, that is just a kind of source country fixed effect. But it depends on in a more complicated way on wages and prices of intermediates through this upsilon, which takes account of the intermediates kind of flying all around the globe through these lambdas. And then that ends up becoming our observable trade share as well for the same kind of argument it would in a Melich-Schnee type. Okay, so now the general equilibrium is pretty simple, but important to get down. So let's see. Total production. So country I's total production is equal to the sum, and this is just in terms of dollars. It's just the sum of its share in each destination, including itself, multiplied by the demand for final consumers and the demand for intermediates. So you just sum up final demand, intermediate demand, sum it around the world weighted by your trade shares, and you get total value of production. And we have now these aren't structural parameters because they themselves depend on, we have a model of those labor shares, or you could say those are the intermediate, the 1 minus beta NL is the intermediate share. Okay, and the alpha NL. The alpha NL is just like the beta NL, but remember with households you replace a beta with an alpha, so that would have been an alpha for the households. Okay, then we're going to have a trade balance, which says that what we can spend on, what the households can spend in country C is their labor income, which is just the sum over all the types of labor income in that country, which ultimately is just the sum over all the task-related wages times task-related employment. But this is really the fundamental, because these LKIs can move around across tasks as demand necessitates, because different type L labor can be used for several different tasks K. Okay, and then the labor market equilibrium, which just says the payments to labor of any given type is equal to the demand for that type of labor in production as well as from consumers. So remember, the YIL is kind of household income, household labor income, a fraction alpha IL of which they're spending on direct labor, as opposed to buying intermediates. Okay, outsourcing means going to Home Depot and buying the float for your toilet and putting it in yourself. That's actually outsourcing because you're buying something, and hiring your own labor means calling the plumber and having him come and fix it. So that's kind of the difference there. I mean, that's a little bit strained, I guess, because he had to go buy the thing. But if he could, maybe it's like he actually just fixes it, whereas you had to go buy a new one and do it yourself. Okay, so now I want to go through a little numerical exploration. I'm going to start with the aggregate. So I haven't got to the firm level stuff. I'm going to kind of keep separate simulating the aggregate. Then with the same parameters, I'm going to look at the micro implications. But I'm going to kind of keep those separate because there's still some stuff we need to know about the firm level part of the model. Okay, so here are some parameters I chose. This is very undisciplined because we're not estimating parameters yet. But look at the theta of 5 pole, not 8.28. We're kind of drifting down. So the phi of 2, the phi had to do with the price, and the difference between the theta and the phi had to do with the extent to which low-cost suppliers are more visible to buyers. Then their technology levels in each country, that number was set to make some stuff cancel out. There's a world labor force of 1. There are going to be 5 countries which are of these sizes here. Really, I wanted to have a huge range of the size of the labor force so I could look at these scale effects of countries. But it all sums to 1. And then I have different types of labor. So in fact, I'm going to have 60% of the labor can't be outsourced. And then there's 40%, which is production labor. So then for the, just a second, I'm saying, no, I said that wrong. In terms of being outsourced, the number, let's start with this one. They're service tasks. These are the tasks that cannot be outsourced. They have a share of 40%, and there are 4 different versions. That could probably just be one type of task. Then their production tasks, which are the tasks that could be outsourced, they have a total share of 60%, and there are 12 of those. The number of tasks matters because that has to do with how many different things there are that a firm would want to purchase. or how many different suppliers it could potentially use. Okay, and then the 0.6 and the 0.4 have to do with the endowments. I misspoke when I first described that. So they're 60% endowment of service labor, that type of labor that can perform those tasks, and 40% of the labor can perform any of these production tasks. So the types of labor is only 2 in this example. We wanted to look at the way in which labor who's kind of trapped in certain tasks gets affected differently from labor who's perhaps more exposed to the forces of globalization. So that was the reason for having the different, that's the reason for having the distinction up here, is so you can look at different types of workers being affected differently by outsourcing. And then the reason for having the multiple tasks is to kind of calibrate it so you get the number of customers right. And then the point of making this not 0 is to make the model stable, and also give a kind of get that so that the size of the manufacturing sector was about right in the overall economy. Francis is working on putting a data set together for us of different categories of labor in France. So that is our goal ultimately, is to kind of connect this model with different labor types in France and the degree to which they were hit differently over the last few decades as trade has increased in France. Okay, so now I have all these different sized countries. So I'm going to simulate a world of 5 countries. Oh, did I say the iceberg costs? I'm sorry, where are they? Okay, iceberg, 20% iceberg costs separating these countries of very different sizes to kind of bring out the scale effect of the. So looking across the top column, you see the share of production value added in GDP. See, it's sort of at the right magnitude, like 13% manufacturing share of GDP. It goes up mildly as you go to bigger countries because there's a slight effect of it being more efficient to do production work in a big market. The share of gross production, the share of manufacturing value added in gross production tends to go down in the big markets because the big markets use a more roundabout form of production because they are these sort of more efficient hubs for doing firm-to-firm trade, because there are more of them where you don't have to bear the iceberg costs. And then you can see that the fraction of production tasks outsourced is going up. And that's going along with the second row, where the share of value added in production is going down and the share of tasks outsourced is going up in the bigger markets. And then the import share, well, that's going to be in a little market, that's going to approach 1. But then for the bigger market, it's sort of in the right ballpark of 40%, probably a little bit on the high side generally for that. So maybe we need slightly higher iceberg costs. Okay, now we can look at what happens to wages holding fixed iceberg costs, but just looking across the scale effect. How much of a scale effect is there in this model? So now what's happening with the wages in the service sector tend to go up because versus the production wages are much less, are rising much less with country size because the production wages are being constrained by the threat of outsourcing, unlike the service sector wages. And in general, you know, wages are going to be a bit higher in the bigger country, which is sort of a more efficient production area. So we see the skill premium, where you see that most clearly is the skill premium. If that's just a word for the service sector wage over the production wage is going up. And then in terms of real wages, the real wage of the production workers actually slightly declines, whereas the service workers get a big wage, real wage increase as you go to the bigger markets. So in the bigger markets, the production workers are in this sort of more competitive environment, and that ends up hurting them a little bit, but not very much. And then we have the overall welfare calculations at the bottom. Okay. Now here's looking at it, the different dimension. Whereas before we were looking across scale, here we're looking across different levels of trade costs, both for a moderately small country and a moderately large country. So let's start out with some of the easy stuff, which is that if you look at free trade, iceberg costs of 1, well then notice the first three numbers are identical. The size of the country is irrelevant other than for the import share, just because a bigger country is a bigger kind of target. So it's not going to, a bigger country is not going to import as much. And then we can see all the remaining numbers are the same if there's no iceberg costs here. Okay, so now let's look at what happens in the small country as you open up to trade, going from roughly autarky here towards free trade. Well, the production sector goes up. So you sort of pull, you move toward the production sector becomes more viable when you open up to trade because you're able to move goods across countries. And so that the share of that sector in the economy goes up. And then the fraction outsourced really goes up from 19% to 57% as you move towards lower trade costs. Now, what's happening to the workers? Well, here you see something more dramatic where the production workers have a nominal wage decline, and in terms of the real wage, a modest real wage decline. Whereas the service workers are really gaining, the ones who can't be outsourced get this huge advantage from the more open economy. In the more open economy, they're being exposed to the competition from abroad and from within the country. But really, in this experiment, it's from abroad. In the previous one, it would be kind of from within the country. And that means their wages being constrained, and the service workers are kind of reaping the benefits of that greater efficiency. Okay, so now let's turn to the firm level implications. I want to do this slowly because every other time I've given this talk, there's been about 1 minute left, and then I rush through and nobody knows what the hell I'm talking about. So we had this aggregate model. Now we're really zeroing in on the firm level connections that are kind of underneath the surface. Okay, so let's think about the Poisson number of customers, or it's actually the number of customers in N for a firm delivering there at a cost C is Poisson with parameter A to N of C. And what does that parameter depend on? Well, it depends on the number of customers, the encounter rate, times the probability that, so I didn't quite say the number of customers. Yeah, this is the number of customers. So they actually have to make the sale. They're going to make the sale with probability 1 minus the probability that somebody else has a lower cost. So they've got to come in. They get a potential customer who they encountered, but then to actually make the sale, they have to be the low-cost guy, and that's what this term is taking account of. So we have the product of kind of the market size, the encounter rate, and the probability of beating out the rivals in terms of cost. Okay, so that gives the number of customers a firm is going to see if its cost is C. And then we can say, well, what's the number of customers they would have anywhere in the world? Well, that's a Poisson. If the firm is in country I, that's Poisson, and it's just the sum of these terms up here where your cost is C, and then it gets bumped up to C times D and I when you're present in some other foreign market N. Okay. So then what's the probability of a firm in country I with cost C exporting to country N? Well, it's 1 minus the probability that everybody, let's see, let me be careful in how I say that. So it's exporting to country N. Its cost is C. Its cost in that market is going to be C, D, and I. E to that is the probability that it will have no customers there, because that's just the Poisson of 0. So 1 minus that is it has at least one customer in that market N. OK. Now, using that same reasoning, but now applied to worldwide customers, you can then derive the measure of firms who will be operating in country I. So you integrate up over the cost distribution of firms who can deliver from country I to itself at a cost less than C, the probability that they'll have at least one customer somewhere in the world. And so that's the number of firms. And then this is the measure of firms from I selling in N. So what do they have to do? Well, they have to have at least some buyer in country N, and then we integrate that up over the cost distribution of the measure of firms from country I who can sell in country N at a cost less than C. And this is going to be key to looking at my relationship from figure 1 of entry versus market size. Because this is basically entry of firms from, say, I equals France. The number of French firms, or measure of French firms selling in country N, is going to get given by this. And we want to see how that relates to the market size of country N. And the way the market size is going to come in is through this A to N, which, remember from here, A to N, well, that's kind of roughly like market size. But we can compute an exact one. But that's kind of the intuition of how market size comes into this. Before going to my final figures, let's just look at how what happens to individual firms in these different size markets. And think about this relative to the picture we saw, the table I showed way at the beginning of the talk, where we looked at Denmark. I can't remember, was that Lithuania, Denmark, UK, and the US. Well, the orders of magnitude here are similar in terms of the different market sizes. OK. So the measures of firms, producing in each of these different size countries just goes up. Now that's kind of uninteresting because, of course, in a bigger country you're going to have more firms buying and more firms selling. So let's look at a normalized measure where we look at the number of firms relative to the labor force of the country. So then what we see is that the number of firms producing in the bigger markets actually goes up relative to labor. So that kind of corresponds to our idea that the bigger country is a sort of more natural manufacturing location because of saving on the trade costs. Whereas the number of firms selling actually goes down, and that's because in a bigger market, you don't have to keep replicating having more suppliers because the same supplier can sell to several customers. So that's more likely to happen in a big market than in a small market. So really, it's cut down in half as we go across that thing. OK. And then the other thing we can look at is just how the mean number of customers per firm is affected. And very much in line with what I was saying about the fraction firm selling, no, the measure normalized by labor selling, we see that the mean number of customers per firm goes up in the bigger markets. So firms enter, and rather than just kind of getting one customer, they get a set of customers when they come into a bigger market. And that's something we saw in the data way at the beginning. And then this is looking at our distributions of numbers of customers. And while we haven't pushed hard enough in terms of getting really big numbers here, like 200 and so on, you can see that qualitatively, these distributions look like what we saw in the data way at the beginning, where most of the time, most firms have only a handful of customers. But at the very upper end, you start to get some action with firms having many, many customers. And that is totally driven by that parameter that says that low-cost firms are more visible to buyers. If we don't have that parameter, this is just, this prediction's terrible. The upper end is like 4 or something like that. So you really need that kind of an effect to capture these kind of data. OK. Then finally, I'm going to look at my entry market size relationship across these 5 countries of very different sizes. And this is what you get. So this is country, the small moving up towards the bigger and bigger countries. And this is kind of the Tom Holmes effect that just very naturally in this kind of model, there are no fixed cost. It's just sort of firms being encountered by customers in different countries. If you go to these countries with more customers, you're just going to naturally get more firms from a given country supplying those bigger countries with more customers. Not only that, it's pretty linear in logs, although a slight curvature to it. Now, interestingly, that same effect that stretches out the distribution of customers per firm helps to get that to be fairly linear. So that parameter is kind of doing 2 good things for us. It's generating a long tail of customers per firm, and it's generating more linearity here in this log-log relationship between market size and entry. But not only that, but the slope is less than 1. So it's not as simple as just saying the market's twice as big, twice as many suppliers, because when firms go into the bigger markets, they're more likely to serve several customers. And so, in fact, the number of suppliers, number of entrants, does not scale 1-to-1 with the size of the market. And what makes up the difference is this relationship, which is as the market size increases, you get more buyers per supplier. So you get these firms having more customers in the bigger markets, and that's keeping that slope less than 1. So actually, I'm going to skip the other table and wrap it up right here.
Because like the slope before was like 0.5, and this one is super, super flat. So.
Yeah, well, actually, yeah, here's the problem. Yeah, this one's still a bit too steep.
Oh, is it? Wasn't it the stuff that you were trying to nail to?
The one that we have in the data, yeah, this one's more like 0.7, and the one in the data is either 0.6 or 0.5. In our latest data, it's 0.5, unfortunately. Like the 1986 data was 0.64, and then we were pretty close, but we're getting a little farther away. I don't know. We have to push a little. I mean, to be fair, this is already pushing a little to try and get that relationship to be pretty good. I mean, I could certainly pick parameters where this would not be as good as it is here. And so what we're finding is this effect is not quite strong enough and not quite linear enough either, although this was pretty noisy in the data. So in the end, so to kind of summarize, so this is kind of a model, no fixed costs, no sort of effects like that, but some of the facts that in the first place led us to fixed cost models. That's not saying fixed costs are wrong, but it's kind of pushing on a story about entry and market size that's not based on fixed costs to see how far we can get. And we hope in the future to explore these issues of interactions of trade and imports and labor.